So let's continue further, guys, and let's dive deep into this concept of Docker containers and why is it required for machine learning operations. So the agenda, as we progress in today's session, it's a hands-on manner. I'll be taking you through the basics of Docker containers and what exactly is this containerization is, and then we'll directly jump into the quick hands-on so that by the end of this session, you'll be comfortable in seeing and working with the Docker file. So that's the main agenda of this session. We'll take up the hands-on approach just like we have taken it with every other sessions that we have got as part of this MLOps series. Now, folks, if you have missed the previous session of the MLOps, I would highly recommend you to check out the YouTube channel of Manifold AI Learning. So go to the website youtube.com/Manifold AI Learning. If you go to the YouTube page of Manifold AI Learning, you'll be able to see all the live session under the live. Okay, so this I can say it's a third session as part of this MLOps series. So let's continue further, folks, and let's look into the interesting concept as part of a learning journey today, that is Docker. So first of all, as part of our MLOps journey, so we have understood about the importance of packaging our code. And then to track the experiments, we have learned about the ML flow. So these are the two key aspects that we have learned as part of our MLOps learning journey. Now, ML flow would actually help me to track the experiment and ensure that I've got the right model which I have used during my during my training and the one that gave me the best performing. That's the model that helped me to track and look into its various hyperparameter configuration as well. Now, in the packaging section, you have learned that the importance of packaging. So once we package the code, it would enable me to perform the source code tracking as well. Now, machine learning application or even the general software application doesn't just end there. It doesn't just end there with the code or with the simple set of files. We have to ensure that the code that is working in my current system environment should be working in the other environments as well. That means I should be able to replicate it. So one easier way to ensure that my code works in the production environment, just use my same laptop, like whatever the laptop that I'm using it for development, use the same laptop in the production environment. But that's not realistic, isn't it? I mean, I might have a 32 GB of RAM and I might have 1 TB of hard disk, but still that's not sufficient if I'm getting 1 million or billions of concurrent requests from the users across the internet. My laptop cannot handle such requests. Now, when my laptop cannot handle such requests, the users will get a bad experience and it's bad for me. So I cannot make use of my laptop. So what is the next solution? Well, the next solution is maybe I'll create a separate laptop. I'll create a separate laptop or a separate server with this configuration with whatever the OS and whatever the libraries that I've installed. I'll create it in such a way so that my users can actually send in the request to my servers that have created. That means my laptop or whatever the server that have created, and they will be able to send those requests. But the challenge that you see right here, when I talk about server or when I talk about a computer, just for a single service or a single application, if I think about bringing up each and every server, then think about the cost. It's going to take a lot of cost. And just take an example. Let's say you are a startup and let us assume that you've got 100 users right now. Now, when you have the 100 users who are trying to access your application, okay, now having 32 GB of RAM and maybe 1 TB of hard disk space just for running that simple application will be an overkill. So that means your laptop will be lying waste. So what did the people came up? So in the old time, so what the technical folks or the deployment folks came up is they came up with the concept of virtual machine. So when I talk about virtual machine, basically we'll have something called as hypervisor. Okay, we'll have something called as a hypervisor. You can think of it as a virtual box, Oracle virtual box or VMware. You can think of those as an example of hypervisors. So this hypervisor will be installed on the host operating system. Let us say my host operating system is Windows. On top of this host operating system, I'll be using my hypervisor, and using my hypervisor on my host system, maybe I will run multiple operating system. I'll be running a Linux operating system, and I'll be running a Ubuntu operating system on top of the usage of this hypervisor. But if I take up this virtual machine approach, the challenge is here this will have its own set of drivers to run the application. This will have its own set of host drivers that is required to run the application on each of these servers, like that is on each of this operating system. And host to run it, it will have its own set of drivers. As you can clearly see, when to run the system itself, I'll take a lot of resources. Now that would result in a lot of slowness in my overall application. And whenever I want to increase the server size, it's not much flexible over here. So that's where the concept of containers came into picture. That's where the concept of containers and the containerization came into picture. Now, when I say containers, so containers are basically the industry standard that we use it today. Just like you can think of it as a virtual machine to run the software application. Now, as I've just described, if I talk about a virtual machine, the virtual machine run the application inside a guest operating system, which runs on the virtual hardware powered by the server's host OS. Now, these virtual machines are actually great when I talk about providing the full process isolation for application. So as I mentioned, we will easily come up with the problem. But when I talk about these containers, what happens in the case of these containers is it actually takes a different approach. It leverages the low level mechanics of my host operating system, and these containers provide most of the isolation of the virtual machines at a fraction of the computing power. And that's the main idea behind these containers. So the reason that we prefer to use these containers when we talk about machine learning or the overall machine learning application, because here the reason that we prefer is first and foremost they are portable. Okay, they are basically portable, so that Docker containers can be run on any machine which has got the Docker installed. Now, regardless of my underlying operating system. So which makes it ideal for machine learning projects, because as a if you think about from the machine learning project, so depending on your application, okay, so like depending on the application, it is vital that you should be able to run it on most of the environment. Like in some scenarios you will be required to host on the Windows, in some scenarios you'll be required to host on Linux operating system. And these Docker, they are lightweight. And the reason that I'm calling it as lightweight, because they are typically much smaller than the virtual machine. And since it is smaller, it makes it, okay, it makes it much faster to start and it makes it much faster to stop. The reason is when you think about machine learning application, it's a high demanding application. It requires a lot of resources. Just for running that application, if I'm taking a lot of resources, think about computing and generating the output from those complex models. So I'll be focused on the one which is lightweight. And these Docker containers can be easily scaled up and scaled down depending on the requirement of the machine learning project. So as a result of this, this makes it an ideal choice when you're working in a project which has got the wide range of workload. So here we call it as scaling up and scaling down of these containers, called as the orchestration of the containers. We make use of various tools like Kubernetes to orchestrate those containers, like bringing up and bringing down those nodes. That is my Docker containers. So overall, if I make use of containers, it will be lightweight. It would make it portable. This would ensure that the project which is working in my local system will work in my production environment as well. And they are scalable. That means it can cater to the changing demand that we see from the users. That makes it an ideal choice when it comes to implementing the machine learning projects. Now, what is this Docker? Okay, Now, like when I talked about it, I've also mentioned something called as Docker container. What exactly is a Docker container? So Docker is a company. So it's a software company, and we actually create the containers with the help of the Docker Hub software. Okay, that's the overall idea, guys, when we talk about the overall idea about these containers. So here, in order to follow along with me to get started, first thing is you need to have a Docker desktop present in your local system. Okay, you need to have a Docker desktop present in your local system. So one easier thing is you can go to the Google and search for download Docker desktop. Okay, so it will directly take you to the page of Docker desktop, and here just download the installation file depending on your operating system and perform the normal installation process. And if you're installing on Windows operating system, it might ask you to install the WSL, and which might require you to restart. Just follow the instruction which is provided by the installer, and if you just follow the normal installation process, you should be good. Now, once you install it in your computer, you'll be able to access it as Docker. In Windows, it is called as Docker Desktop. In Mac OS, it is called as Docker. Just run that Docker and you will be able to see an icon that would look like this. So this is the icon of the Docker. So if I click on it, it says my Docker Desktop is running. Okay. Now, once you have installed the Docker Desktop, you can test it whether it is working or not. In your Windows operating system, you can make use of Windows PowerShell or the command prompt. And in Mac, just launch your terminal. I'm going to launch my terminal. Now, once I launch my terminal, so just run the command, that is docker run hello world. If you run the command of docker run hello world and press the enter key, okay, so this would actually what it does is it will run the Docker container. So it will run the Docker container, and it will give us a message which says as hello from Docker. This message shows that your installation appears to be working correctly. So this is a quick check that you can do to validate that whether the Docker is working in your system or not. Okay, so that's the overall idea about this installation process, guys. It's a pretty basic. Okay, you can refer to the sessions recording at a later point as well to follow along with me, even if you're not in front of the system. Okay, so with this, your system will be set up. Now, let's understand some of the important basic commands and important things about the Docker. So here, when we talk about the architecture, so when I talk about this architecture, I'll directly take you to the page of this Docker Hub, that is their Docker documentation. So here, this is the official documentation of this Docker. And here, when we talk about the architecture of this Docker, it basically uses the client server architecture. Okay, we have a straightforward client server architecture. So we have something called as a Docker client, and this talks to the Docker daemon. So you can think of the Docker daemon as a server. Now this Docker daemon is the one does the heavy lifting, which is nothing but building of the container, running of the container, and distribution of this Docker container. Okay, so that's what this Docker daemon does. And the Docker client and the Docker daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon as well. Okay, so that means I can have a client in one system, or I can have a daemon in another system. And this Docker client and the Docker daemon, the communication, it happens between them with the help of REST API over Unix sockets or the network interface. And another client is what we call it as Docker Compose, which will help us to work with the application, which is going to consisting of multiple set of containers. Like we'll be generally making use of Docker Compose whenever I've got an application, machine learning application that is running, and I'm tracking it with the help of Prometheus. I'm trying to capture the log, and then whatever the logs that I'm capturing, if I want to generate those visualization using the Grafana, so that's when I'll be making use of Docker Compose to bring up my machine learning application, Prometheus server, and the Grafana, which will help me to achieve the continuous monitoring of the machine learning operation. So that's where I'll be making use of Docker Compose. So when we talk about Docker at the end, it will help me to create the containers. So here it works on client server architecture. The commands and the communication will happen through REST API. So I hope that's clear for everyone now. So folks, if you're able to follow along with me, please confirm by typing as all good in the chat window. Thank you, Dheeraj. Thank you, Rakshit. I can see few more responses. Okay. Thank you, Damayanti. Okay. Chris. Okay. Thank you, Daniel. Thank you, Rishikesh. Perfect, guys. Thank you so much for being so interactive and responding to the same. So let's continue further. So you have understood the idea. Now let's look into this architecture. So through the client, okay, through the client, we'll be running the commands. Now, when I run any command, it will be sending to my Docker daemon. You can also think of it as a Docker host. Okay, so whenever I run any command from my client, the request will be processed by this Docker daemon and it would interact with the other components as well. Okay, now while you can learn more about the same, so Docker daemon listens to the Docker API request and manages the Docker objects like images, containers, networks, and the volume. And Docker client is a primary way in which we interact with the Docker daemon. So some important terminology which you need to be aware from the Docker perspective is the Docker objects. That is the images, containers, and yeah, these images and containers are very important, and we also have the volumes as well. So let's start with the images. So what does it mean by a image in the case of Docker object? So when I say image, image is basically it's a read-only template and which contains the set of instructions which I'll be using it to create a Docker container. So which means that image is basically the set of instruction. You can think of it as a document. Okay, now I'll be using this document. I'll follow the instruction and then I'll create an instance from this Docker image, and this instance is what we call it as Docker container. I'll call it as Docker container. Now, whenever we are working, so generally if I want to create an image, so I'll be referring to the another image as a reference, like I'll use another image itself as a base, and based on that I'll be building. For example, if I talk from the machine learning perspective, let's say if I want to build a Docker image for my machine learning application, first I will start with a Python image where the Python image already contains the Python installed inside it. I'll choose the required version of the Python, and then on this Python image, I'm going to add my own customization. We call it as the layers. On this Python image, I'm going to take care of the installation of my requirements. I'll go ahead and execute the program. And if required, I'll go ahead and run the application. Let's say I have deployed my application as a fast API. So with the help of fast API, let's assume that I have exposed my model to the interface, like to the endpoint, that is API endpoint. So I'll be running all these things and I'll mention all those instructions inside this Docker image. Now, when I create a container, all these instructions will be followed. So I'll get the Python image from the Docker Hub, that is my repository. Then I'll be performing the customization as per the requirements.txt if I've got any. Then I'll go ahead and perform the execution of the program if there are any. Maybe I'll go ahead and run my application as well. So that's how we'll be making use of the Docker image and creating the containers. See, it says that you might create your own image or you might use those created by others which are published in the registry. Registry, you can think of it as a place where everyone have shared their work. Okay, you can think of it as GitHub for the Docker containers. That's what you can think about it. Okay, and we have a container. So this is a runnable instance of an image. And here while working, I can create a container. I can start the container, I can stop the container, I can move the container, delete the container. I can do all these things as per my requirement. Okay, that's the basic idea of Docker images, and the Docker containers. Now here, the set of instructions that I would use to create the container or to build a Docker image is present inside a file that's called as Docker file. Okay, that's the overall idea, guys. We'll be making use of this Docker file. Now, since we are starting for the first time, let me just give you a quick hands-on way as how do you get started, and then I'll take you through the other parts as well. Okay, I'll be sharing all those things in the repository as well. So let me just start by running the hands-on. Okay, so what I'm going to do is I'll create a new repository over here. For today's session, I'll create a new repository and I'll mention all the commands which we'll be discussing as part of this today's discussion. Okay, Docker for ML. I would open up the folder which I've created just now. So the repository that I've created is called as the Docker for ML. So here I'll be using all these commands, and anyways I'll be showing you these as well. Okay, so here let's start by executing the basic commands. So here, first thing is, whenever we install that Docker, okay, we can display the version of Docker by running the command as docker -- version. So when I say docker -- version, it will display the version of the Docker that is running. Now, if I've got any container that is present with me, or if I want to run any container, okay, whether it is present in my system or not, if I want to run any container, I can make use of the command of docker run. Now, when I execute this command of docker run hello world, so what is happening through my CLI, okay, command line interface, you can think of it as a client. Through my client, I'll be running this command docker run hello world. So what it does, so this client is going to send the request to the Docker daemon using the HTTP protocol, that like the communication will happen through the HTTP. Okay, next here it will send the request to the Docker daemon. Now this Docker daemon, what it does is it will check whether I have the hello world image present in my local system or not. Okay, so if I open up my Docker desktop, if you look into the images in my current system, I have a hello world Docker image, that is the image is present in my local system. So the CLI is going to send the request and the Docker daemon is going to search whether this image is present locally. Okay, if it is present, it will go ahead and perform the execution, that is it will run this container. It will perform the activity of docker run and it will run this container. In my case, observe, I have a container present. Okay, now I'll open up my terminal and this time I'll say docker run hello world. And if I press the enter key, see, it did not download anything. It directly ran the output for me. It simply ran the output for me and it says hello from the Docker. It did not download. The reason it did not download from the Docker Hub, because here it is already present. It is already present. Now if I go ahead and let me delete all these containers that I've got, okay, and delete this image. Now if I come back and run the same command, that is docker run hello world, see here it says unable to find the image locally. Then it is pulling the image from the Docker Hub. Once it pulls the image, then it will run that image. So that's the overall idea of this docker run command. It will help me to run the container. Now if I simply want to pull a container from the Docker Hub, we call it as a Docker registry, so I can make use of the command of docker pull. So I'll just say docker pull busybox and I'll press the enter key. So here when I say docker pull busybox, it will pull the container and it will download from the Docker Hub and it will save it locally. Now I can display whether this image is present or not by running the command of docker images. when I say Docker images, it will display all the images, Docker images that I've got in my local system. I've got BusyBox, I've got Hello World. These are the two images that I've got right now. So Docker images will help me to display the images that I've got in my local system. Now that I have downloaded it, I've just mentioned that I can make use of the command of docker run. Okay. So I can make use of the command of this docker run and run it. So let me just say docker run busybox. So when I say docker run busybox, we can see that nothing has actually happened. I mean, I just got the output. Let me rerun it again. I'm seeing nothing as an output. Well, the reason that I'm not seeing anything as an output because here inside the busybox, okay, there's no configuration which says that print something to the output. It just executed the whatever that is instruction that is present inside the docker file. Remember, I'm not talked about the docker file yet. So it just executed some instruction and it actually ran the container. That's all. That's what it did right now. So what it means is when I say docker run busybox, here it did not give me any output. Now if I want to display the images like the current containers that are running, there's a command that's called as docker ps. So docker ps is going to display all the containers which are actually running. So when I say docker ps, it will mainly display only the active containers. Now when I say docker ps -a, it will display all the containers. So here it says I have actually ran the busybox twice and it was created 55 seconds ago and another one was created a minute ago. That means it actually started this container. Since I did not mention anything, it just exited that container. Okay, that's the overall idea right now. Now, if I want to do something on this busybox, I can say docker run, okay, and I'll mention this container, let's say busybox, and I'll just say hello from busybox and I'll press the enter key. So here it gave me an output as hello from busybox because this time I ran a Linux command of echo which will print the output to the screen. Okay, so that is how we can go ahead and run any container and I can mention what exactly that I have to do when I'm running it by following the commands that I want to specify. Now, this is about running. Now, if I want to stop any container, then I can say docker stop and mention the container ID or the container name. Okay, in this way, I can perform the stopping. If I want to remove it, I can say docker rm and I can mention my container ID or the docker container name, which will help me to remove that docker image. That is my docker container. Okay, that's the basic idea about the basic commands. So we have looked into the commands of docker run and docker run busybox, docker ps -a, and yes, this is important. So when I'm using this command of docker run, okay, when I'm using this command of this docker run, I can also send in the flag of it. Okay, I can also send in the flag of it. This would actually execute my container in an interactive mode. Like I can say docker run -it. Okay, so execute it in an interactive mode and run the container or run the image of busybox, and I'm saying it as sh, that means run it as shell. Now if I press the enter key, see, previously my command line interface was saying it as Nachiket Manifold AI Learning, that's my username. Now it is directly mentioning it as hash, which says that whatever the command that I'm running, it will be running inside this container and not inside my desktop, that is not inside my laptop. See, ls, it is going to display the list of folders and files that are actually present inside my container. Okay, this is the basic of working with the docker containers. So just to give you a quick background again, quick recap, version is going to display the version. This will run the container. If the container image is present, it will use the existing image, else it will download it from the Docker Hub. Docker pull is going to pull the container image from the website, that is Docker Hub. Docker images will display all the images that I've got in my local system. Docker run will run the same, and depending on the configuration that I've set in my Docker file, it will do the activity as I've mentioned. Okay, and then let me close it. Yeah, then we have looked into the Docker PS that will display the list of active containers. Docker PS-e displays both active and inactive, and I can send in the flag of IT, which will start it in an interactive mode. And RM is going to remove the container, and we can also go ahead and stop the container as well. So this is about the basics of working with Docker. Now, it just doesn't end here, guys. I want to take you few more things. So I'll take you some few more things which would help you the same. Okay. So here, the next thing that I'm going to show you is I'm going to execute this command which says as docker run, and I'll say -d. That means run it in a detached mode. That means run this container in the backend. And I'm saying it as -p. -p means expose the ports that I've got inside this container. Okay, and I'm going to say it as use the name of cat.gif whenever you're creating the container. Okay, and the cat.gif, you have to get it from the repository of Manifold AI Learning, and the repository name is cat.gif. So before itself, I've already pushed into my Docker Hub. So if I go to this Docker Hub, okay, let me log into my Docker Hub and I'll show it to you. See, if I go to my Docker Hub, there's already a repository that I have pushed in, that is cat.gif. So I'm going to pull this cat.gif and I'm going to run a container. That's what it is going to do when I run the command. So I'll just copy it. Okay, and I'll launch my terminal. I'll just press the enter key. So it says unable to find the image. So hence it would go ahead and fetch the image. Okay, so it is downloading the image. And then once it downloads, so it is going to expose all the ports that I'm trying to expose over here. Okay, this concept of port exposing is very important, and that's the reason that I've selected this example. And then I've got a container ID. This is the container ID. Now when I say docker ps, see, I can see that. Okay, let me just minimize a bit so that you can see everything in the same page. Okay, so now you can see that this is my container ID, this is my image, the command that is running is python app.py, and what it says is it has exposed the port inside the container of 32768. It has randomly selected the port 32768 port of inside the container is exposed to my local system, that is my host port of 5000, and the container name is cat.gif. So what I'm trying to tell you is there is a container that is running, and this container contains a Python Flask application, and it is exposed to the port of 32768 inside my container, and I can connect to it through the host computer. In my case, the Mac OS, what I'm running. In my Mac OS 5000 port, I can access this port of 32768. And I'll be able to access this application which is running inside this container. So let's go ahead and check the same. So I'll open up my browser here. I'll just say localhost. I hope it's 5000. Okay, let's see. I think it's 127, I guess. Yeah. Let's see. Or okay. I believe this is what I have to go, 32768, I believe. I'm sorry, guys. Yeah. Okay. So what it means is it's the other way around, folks. So my host port of 32768 is connected to the Docker container port of 5000. So now if I go to the port of 32768, I've got the output. So it is trying to process the output. Maybe it has got some networking issues, but here I'm trying to get the output right here, which is going to display some cat GIF image of the day. That means I'm able to access the application which is currently running inside my Docker container. See, I've got the current container which is already running, and I'm trying to access this application by going to the port of 32768. Now in this example, 32768 is the randomly assigned port. Now, if I don't want to give it random, if I want to go ahead and assign it to the required port, then I can mention it in this way. Docker run. I can make use of the flag of -p and mention the required port. Let's say in this example, 8888 to 5000 inside the container, and I can mention the image. Okay, so let me just show you the same. So first I'm going to stop the container. In order to stop the container, I can say docker stop and mention this container ID. So this will stop my Docker container. Now, once the Docker container has been stopped, I can go ahead and run this again. I can go ahead and run this again. So here, when I'm running it here, okay, so since I'm running it in the foreground mode, okay, I'm able to see the output here, which is being exposed by my Flask application that is running. So here, now I can go to the port of 8888. See, I can go to the port of 8888 from my host system, and I'm now able to access the application. Okay, I'm now able to access the application. So that is how you can connect your host system to the Docker containers port by sending in the flag of -p. Okay, these are the commands that I've run. So let me just paste it right here for you for a reference. Okay, so this is the command. Now, what I've mentioned, in order to build the container, we'll be making use of something known as Docker file. Now let me just give you an idea as how does a Docker file would look like. So if I take you with this example, okay, I'll show you a simple Docker file and how it actually look like. I've just copy pasted this code and I'll show it to you. Okay, this is the Docker file example. When I say Docker file, it's a text file. There's no extension towards it. So you'll just say Docker file and you will mention the code. So if you look into this Docker file, what is happening is I'm saying this as from Python 3.8. That means I'm going to get a base image. Okay, I'm going to get a base image which is Python 3.8. Now, inside the container, I'm saying this as there is a folder. Okay, set the folder of user src app. Set the directory as the working directory. Now, what I'm saying is inside that app folder, think of it in this way. So there is a user. Inside the user, there is an src. Inside that src folder, there is an app folder. And inside this app folder, copy all the files to the container. So in my case, I do not have any file. So let me just go ahead and place a file right here. I'll take the help of my other repository and I'll just go ahead and mention a file right now. Okay, this is the file that I'll be using. So I'll just say app.py, which is my Python script file. So basically, this is a Flask application. If you look into the Python Flask application, so in the index page, it's going to display some output using the template of index.html. So I'll create a folder of templates. Okay, inside this folder, I'll just have to mention the code of my index.html. So in order to render this Flask application. So here, this is my index.html. Let me just go ahead and create the file. Okay, so once I've created this file, okay, so this can actually go ahead and like run this Python Flask application. And here, if you look into this Python Flask, I'm exposing to the port of 5000. That is what I'm doing right now. And for the home page, I'm rendering with the home page of index.html. Now to ensure that it works inside my Docker environment, if you look into the commands right now, so I'm going to refer to this requirements.txt file and install the dependencies. So that means I don't have a requirements.txt file. Let me go ahead and create the same requirements.txt. Now inside this requirements.txt, I can mention the dependencies, whatever that I have got. So like in this example, I can mention the requirements like the Flask. Flask is a requirement. Flask library is a requirement. I can mention it as a requirement inside this Flask is equal to 2.0.2. You can mention the required version. Okay, so what I've got right now is this repository is now containing a Python application which is running on Flask. Now, what is this Docker file? This Docker file contains the set of instruction which I have to read it in order to build a Docker image. Okay, basically the set of instructions. So here, if you look into the observe now, right now, first I'm getting a base image of 3.8. I'm setting the working directory of the application inside the Docker container, and I'm copying the files which are present in my current working directory. Like current working directory is everything that is present right here inside this folder of Docker for ML. Everything that is present inside this folder is being copied inside the container. Now, once I've copied, I'm making use of this requirements.txt file, and then I'm performing the installation. Then I'm exposing the port of 5000 from my Docker container. Okay, I'm exposing the port of this 5000 from the Docker container. And finally, I'm running the command of python app.py. That's it. This is the set of instruction that will be used when I'm trying to create a Docker image. So if I want to create a Docker image, what I need to do, so I'll just go to the folder. So currently this is in my desktop inside the folder of author repo, Docker for ML. Okay. Inside this Docker for ML folder, I've got the files, Docker file, readme file, app.py file, requirements.txt file. Now, if I want to build a Docker image, then the command that I would use is docker build -t followed by the Docker repository name that I want to specify. Like for example, I'll say docker build -t catgif v2. Okay, and followed by I have to mention where exactly my Docker file is present. The context, we call it as a context from the software development perspective. So we'll have to mention where exactly my Docker file is present. I'll just say dot. Dot refers to my current working directory. If there is a subdirectory, then I'll say dot slash and specify that folder. In my case, it's a current working directory. Ensure that you mention the dot here, and I'll press the enter key. See, now it is building the Docker image. It is getting the Python 3.8 first, and then it will build the various layers. It will copy all the files from my local system to my Docker container image, and then it will build the overall image. Okay, all these steps it is happening right now. Okay, now once this is done, if I say Docker images, you can see that a new repository, that is catgif v2, has been created just few seconds ago. Now, if I want to run this container, I can say docker run, okay, -p. If I want to expose it to a separate port, I'll say 5000, okay. I'll just say 5000 to 5000. Okay, what is it that I want to run? I want to run this catgif v2. Okay, so if I want to run it in a detached mode, I can also say docker run -d, which will run it in the detached mode. Okay, so it says ports are not available. Okay, it's because I'm actually running different application in the backend in the 5000 port for my Prometheus and Grafana for a personal project. So let's use the port of 1234. Okay, now it is running. So I have exposed the 1234 port to the 5000 port. So now I can now go to the port of 1234. Okay, is it the other way around? Let me recheck, guys. I think let me docker ps. Okay, I think there is an issue right now. Okay, I think it's not running. So let me just run it in this way. I'll just say docker run. Okay, this would expose. Okay, there are some issues right now. So what it says is it cannot import URL code. I think there are some issues. It looks like, okay, there are some issues over here. Let me try to resolve it. So let's just try to run it locally. So if I running it locally, okay, 5000 is already in use. That's what it says. Okay, let me run locally team, but that's the overall idea. So I'll just say 1, 2, 3, 4. Okay, it is running locally. So it is now available in the port of 1, 2, 3, 4. See, it is running locally right now without any issues. So it looks like, okay, yeah, it is trying to connect to the same. That's fine. So, uh, so I hope you got the idea, guys. So that's the overall idea of working with this Docker container. So it's working locally, maybe due to some issues over there. So I think it's unable to replicate it. So we can recheck and look into it at a later point. But I hope you have got the idea. So let's see it in this way. I'll just expose it to the port of 1, 2, 3, 4. I'll do one more trial. Okay, I'll build the Docker image again. Okay, now once I build the Docker image with the Python 3.8, okay, one reason could be is the Python version. Then I'll go ahead and run the command of docker run hyphen p. Okay, 1, 2, 3, 4 to let's say 1, 2, 3, 4 cat gif v2 dot. No, cat gif v2. I think that's enough. Okay, so it looks like from Flask render template, and that itself is having an error. Okay, it could be due to the version that I'm using right here. Okay, let me change the version to Python 3.10, and instead of the Flask 2.02, I'll just let it use the latest version. Now let me rebuild again and we will rerun it. So once that is done, I'll rerun it again. Okay, so it is running right now. Now I can go to the port of 1, 2, 3, 4 and I can now access the same. See, now it is actually running. I can now go to the port of 1, 2, 3, 4. So that's how I can build a Docker image, and I can go ahead and bring up the container as well. Now, how can I extend the same concept to the machine learning models? Well, to give you the demonstration of the same, so what you can think about is, okay, so here, let me create another file, okay? I'll call it as main.py. Okay, that's the file that I'll be using. And here, let us assume that I've got a machine learning model. Okay, so let me show you with the help of Fast API. Okay, so we can make use of various things. Maybe in this example, okay, I'll be exposing the model with the help of Fast API. So there are various ways of doing it. Fast API is an easier way when it comes to working, guys. So that's what I'll be using it right now. Okay, there are a few more things. I'm just validating. Okay, Fast API is what I'll be using it. Now let's go ahead and train a machine learning model. Okay, the way that I'll be training is, okay, so maybe we'll launch a Anaconda prompt, and here I'll go ahead and create a model, and I'll create a new notebook right here so that you'll have it as a reference. So what I'll do is from sklearn.datasets, we'll be importing the load iris. Okay, then yeah, I'll say iris is equal to load iris. Okay, this will go ahead and fetch the data set, and this iris data set I can access it by calling as iris.data. Okay, this is what I've got. So what I'm going to do is I'll just go ahead and I'll import my joblib, and we'll train a simple machine learning model. I'll just say from sklearn dot uh, linear underscore model will simply implement this logistic regression model. Okay, so I'll just say logistic regression, and I'll create a model logistic regression and fit x here. I'll say iris dot data and iris dot target. Okay, so I'll just go ahead and perform the fit on this given data set. Now once I perform the fit, I'm going to save the model. So I'll say joblib.dump, and here I'll be saving the model as final underscore model dot pkl. So this is what I've got. Okay, it says file name. See, okay, I'll have to mention the model, that is logistic regression model final model.pkl. So I've actually saved this final model.pkl, that is in this final model. Now, what are the requirements that I've used right now to perform this execution? See, currently I'm running the Python. So currently it's a Python version 3. I'll use the Python 3.10 and I'm making use of sklearn library. So here, let me look into the version of the sklearn library. This is important. So the sklearn version is 1.2.2. So in my requirements.txt file, so I would just say learn is equal to 1.2.2. Okay, then what else I've used? I have actually made, like if I want to generate the prediction, I'll be requiring the joblib. So let's look into the version of joblib that I've used. So joblib, I think this would come by default, but let me just revalidate it. Okay, 1.2.0. Okay, this is the version that I've used. So in my requirements.txt file, so joblib is equal to 1.2.0. Okay, so that means if I want to generate the prediction on the new data set, so I should be sending these values, like I should be having the scikit-learn and the joblib. Now I've got the model file, which is final model.pkl. So what is the next only thing that is pending? See, the only thing that is currently pending right now is basically exposing the model that I have created as an API. So that's the only thing that is pending. So if I want to expose the model as an API, there are various libraries that are available. Since we are looking at an easier way, we can make use of a library that's called as Fast API. So this is a lightweight library, which is a framework that will help me to expose my model as an API where anyone can send in the request. So I'll just make use of my other boilerplate codes that I've got where I've already implemented, and we'll implement it for our examples as well. So yeah, I'll take up an example right now. Let's take up this. Okay, so I'll copy this code and I'm going to paste it right now. Okay, inside my main.py file. So here from Fast API, and be importing this Fast API. And in my root, that is in the home page, I would mention it as hello from Fast API. This is my iris model. Okay, and if someone comes to this predict path, okay, if someone comes to this predict path, if someone makes a request to the predict path, then what I will be doing, I'll be running an application. So the way that I'll be running this application is here, I'll have to load the model. Okay, so that's an important thing. So whatever the model that I've got, in my case, the model is basically my final underscore model.pkl. That's my final model that I've got, and I'll be importing my joblib. Okay, this is going to load the model. And if someone sends the data to the prediction, see for this predict method, if I want to generate the prediction, I actually have to send 4 inputs. That is, in case of iris data, it is petal length, petal width. So those values, right? I'll have to send in those values. So what we'll be doing is when we are getting the data, we can create any application, something like this. Okay. What I'm going to do is for the easier processing, let me do it in this way. Okay. Yeah. Let me just implement this parsing as well. That would help me. Okay, I'll just implement this parsing right now. So here for parsing, I'm making use of the library that's called as Pydantic. Okay, that's something that I'll be using right now. So Pydantic is a library that we use it whenever we want to parse the data. So okay, let me not complicate it since we have not discussed about Pydantic in this session. I'll make use of the straightforward way of implementing the same. Okay, so let me take up this example right now. So we'll directly implement it as a function. Yeah, it makes sense now. So what I can do is, if someone sends in any data for this predict, I'm going to run this predict function. Okay, so this predict function actually receives 4 input. Okay, I'll say feature 1, which is of floating point value. Okay, I'll just call it as feat 1, that is nothing but my feature 1. In the same way, I would receive 4 inputs. Okay, so I'll say feat 2, this belongs to the floating point, and feat 3, this belongs to the floating point. Okay, and feat 4, which is all again another floating point value. Now whatever the values that I would get, I'll I'll just go ahead and get the data. I'll just say data is equal to, and I'll say it as feat 1, feat 2, okay, feat 2, feat 3, and feat 4. Okay, this is what I'll be creating right now. Now let me just complete the code. All right, team. I have done the coding right now. So what I did was I implemented a predict method where it will take 4 features. Okay. I've just placed it inside the list inside a list, which is one of the requirement when you want to generate the prediction. So then call the predict method on the given data set and return the prediction as result. That's what I'm doing. It's a simple method, and this would expose my model as an API. Okay. Now what I'm going to do is if I call this, if I call this function, if I call this overall script, okay, so I'm going to mention it in this format. I'll just say if I call this script, I would mention in my code as, okay, so if name is equal to main uvcon dot run app, which is nothing but the app, object that I've got, and I'll be running on the port of, let's say, 8000. That's the port that I'll be running. So inside my Docker file, my code is going to change. So inside my Docker file, I'll use the Python 3.8 and I'll copy whatever that is present right now inside the app folder. Okay, I'll copy all the files to this app folder. I'll perform the installation, which is present inside my requirements.txt file. I'll expose the port. This time it is 8000, and the command that I want to run is python dot, in the same folder it is main.py. I'll be running this Python script. So before I actually show you in the Docker container, let me just show you directly as how does this overall output would look like. If I say Python main.py file, okay, so there's no module fast API, okay, pip install fast API, I'll do it right away. Okay, so let it install. Now I'll call Python main.py. Okay, I'll also have to install uvcon, pip install uvcon as well, which means I'll have to mention it inside my requirements.txt file as well. Then let's run this Python script. So now the Python script, it is running. Okay, I'll have to import the uvcon right here. Now it is running. It is exposed to the port of 8000. Now the best part is I'll show you the magic, guys. So if I come to the port of 8000, it says hello from fast API iris model. And if I go to the docs, that's the beauty of this fast API. I can get the user interface here. I can try out. I can say try out and mention some values. Let's say 2, 2, 1, and 5 or something. I'll click on execute. This will give me the output from the model. It is saying me some output error. It says cannot convert dictionary. Okay, so let's see what is it. So it is basically having some issues whenever it is trying to unpack or something. Okay, I think I think that's the overall idea, folks. So basically what you have seen is, so we are able to see that how we can expose it with the help of fast API. And we actually learned about the Docker containers, running those Docker containers using the Docker images, how we can construct the same.